well, let's look at number 1. Now, before we even start that, I'm going to take this guy out. Let's imagine you're renting the bicycle and it's $2 per hour. Well, the independence hour, the cost, will be over here. 0 hours, 1 hour, 2 hours, 3 hours, and 7. And here we're going to go by 2s. So if you rent the bike for 1 hour, it'd be $2. If you rent the bike for 2 hours, it'd be $4. 3 hours would be $6, right? Notice that this, at 0 hours, right? If you don't, what do you call? If you're not riding the bike and the timer hasn't started, you're paying $0. And it would be a proportional relationship because it goes through the origin, right? But in this case, it's not a proportional relationship. Still linear, but not proportional, right? It's still being of a straight line, but here, slight difference. So again, 0, 1, 2, 3 hours. And here's again my cost. I'm going to go differently here. And here, I'm going to go by 20. 40, 60. So think about this for a second. You go, you rent your bike, and then they say there is a fee. And before you even pedal, you're already here. At 0 hours, you're just filling out the form, you sign your name, pay by signing your credit card, your invoice, and guess what? You haven't even gotten on the bike and you're already down $20. So after that, at your first hour, how much would you be paying? Well, you'd be $20 plus the $2 per hour, so you'd be right a little just above it, $22, and so forth, so forth. So your line would look like this. But notice that this graph and this graph are a little bit different, right? So this, my y-intercept is at 20, and here my y-intercept is at 0. What explains the difference? Well, here there's no that extra fee, extra charge, and here there is. Okay, so this is proportional. I just want you guys know this, but proportional, not proportional. Both linear, proportional, right? But a little difference because of that $20. So y equals, and this would be $20 or 2x per hour, x represents the hour, plus $20. Now the repair shop charges $50 plus $25 per hour. So again, y equals the $25 per hour, so plus that extra charge, $50. Okay. So far so good. Candle. So we have a candle, right? And then it's half an hour, half an inch. You lose half an inch, so half times x, because that's my slope, minus 6. Oops, sorry. Start again. Sorry, the candle is burning at half an inch per hour, so your slope is negative because you're losing half an inch per hour times x, and then and the candle starts at 6. So if I were to graph this, and that's what I was going to do, right? So I think sometimes it's easier to graph. So this is my hour, and this is the height of my candle. Height of the candle. So imagine right now at 0 minutes, you haven't lit the candle yet. How tall is your candle? Well, your candle is right here. So you do have a point. You have that at 0 hours, your candle is 6 inches tall. After 1 hour, 2 hours, 3 hours, 4 hours, what's going to happen to your candle? Well, it's going to go down, right? It's a negative slope, so it's going to go down. So if you think about it, after 1 hour, you lose half an inch. So at 1 hour, your candle is going to be 5.5 inches tall. At 2 hours, well, your candle is going to be 5 inches tall, and so forth and so forth. So that's the relationship. So this is the relationship, the relation, I should say, right? And this is our function. So if I asked you, hey, at 5 hours, what's the height of the candle? Well, at 5 hours, so here's your input, your x, and you want your output, your y. At 5 hours, what's the height of the candle? Well, you would go y equals, and we're going to plug in this 5 over here, so half times 5 plus 6. Y equals a half times 5 is 2.5, so negative 2.5 plus 6. And y, the height of your candle, would be 3.5 inches tall, and so forth. So with this, you can find all the relations. The temperature is 15 and expected to fall each hour during the night. So again, this is, again, if you think about it, as of now, right now, temperature is 15, and it's going to be decreasing, right, throughout the evening. And so it's 15 degrees right now. If you go 1 hour from now, it's going to be 13, and then it's going to be 11, and then 9 and 8 and 7 stuff, and like that. Because we know our slope is negative, we're going to have our line here is decreasing, our slope is negative, so it's minus 2x. And what do we start with? We started at plus 15, which represents our starting point, which is positive 15, or aka our y-intercept. 4, computer technician charges 75 for consultation plus 35 per hour. Okay, so I'm going to graph it again. This is my hour. This is how much money I have to pay this guy. So he doesn't even start looking at my laptop, and guess what? He's already charging me 75 bucks. Okay, and then after that, it's going to be $35 per hour. So at 1 hour, right, he is already charged. So if you add 75 plus 35, I'm already down 110. So I have points on this graph. One of the points would be 1 hour. I'm down 110. At 0 hours, I was down 75 bucks. That's how much I paid him, right? And with that information, you can find the slope. But we don't need to do y2 minus y. Well, we know already the rate of change is given to us is $35 per hour times x plus a $75 fee. Sorry. Next one, the population of Pine Bluff is 6,791. It's decreasing at a rate of 7 per year. Okay, so 7 people. Again, if you were to graph it, and let's graph this. This would be year. This would be the population. So our starting point, it says is right now, at this year, let's start keeping the records for this town. And we know that's 6,791. So the moment I start keeping records of this town, it has a population of 6,791. So after 1 year, what's the population? Well, it's going to decrease how many? 7. So 6,791 minus 7 is 6,684. Let me just make this a little better. So right now, the population is 6,791. After 1 year, it's going to be a little bit lower. It's going to be 6,784. There. We have 2 points, so we can start graphing this. Right? So our rate of change is 7 per year, so negative 7x. Remember, it's decreasing. Plus 6,791, because that's our starting point. At 0, we have 6,791 and our y-intercept. 7, okay, in 1995, the time when I started recording the population in Orlando, okay, I'm going to write 0 here, but I want you to think of that as 1995 as well. Okay, so the moment, the first year I started recording the population, 1995, there was 175,000 people. This is years, and this is people. At that time, the population was growing at $2,000 per year, 2,000 people per year. Write an equation, slope-intercept form, to find the population for any year. So, given that, I have the rate of change, it's 2,000 per year, right there, per year, and this is my year, plus 175,000. Well, that makes sense because if this is 0, the year that I started recording, 1996, which is 1 year after, let's call that 1 year after. Well, how many people would I have in this town? Well, it would be 2,000 times 1 plus 175,000. And y, right, would be equal to 177,000. So in 1996, I would have 170,000 people. And we could do this for year 2 or 1997, year 3, 1998, and so forth. But then here, they ask me, what's the population? Let's make a prediction. In 2010, well, 2010 is how many years after I started recording the population? Well, 2010 minus 1995, this period of time here is 15 years later. So let's use this function. So y equals 2000 times how many? 15 plus 175,000. That's equal to 30,000 plus 175,000, which is going to give us 205,000. So y, so in 15 years, right, it's going to be 15, my x, this is my x, sorry, and y here is going to be 205,000. Nine, couples are marrying later. That's for sure. The median age of men who tied a knot for the first time in 1970 was, okay, again, I need you to pretend that you're just recording this information. You just started because you're curious about this and you started recording. So in 1972, so let's call this 0, and 0 is actually 1972. There again. All right, so this is 0, but 0 is the year we started, 1972. And you know that in the year that we started keeping data, this is years. This is the marrying age. Okay, 1972, or the year I started recording, men's age was 23.2. In 1998, the median age was 26.7. Where's 1998? Well, let's put 1998 here. But in terms of how many years after I started recording, that's 26 years. So this would be 26 years. Right? 0, 1973 would be year 1, 1974 would be year 2, and so forth and so forth. So 26 years after, what is that point here? That's what we're looking for. So let's write an equation. Oh, actually, we do know. In 26 years after, in 1998, the median age grew to 26.7. Men started getting married even later. So they want the equation. Well, don't I have 2 points? I have the first point here, 0 and 23.2. Then I have my other point right here, which is 26 and 26.7. Okay, so we can find the equation of the line. We can do m equals, and let me call this y2, x2, x1, y1. So we did 26.7 minus 23.2, 26 minus 0. I think it's 26. Yep. So on top, we're going to get 3.5. At the bottom, sorry, it's not 26. Why do I keep saying 26? 19, yeah, no, it's 26. Yeah, that's correct. Or 26. That's my slope. M equals, so M, so let's write the equation. Y equals 3.5 over 26x, because that's my slope. Is there a y-intercept? It's right here, ladies and gentlemen. Plus 23 by 2. Okay. And then at the bottom question says, what happens in 2005? Well, let's make 2005 right here. What is 2005? How many years is that from 1972? So 2005 is 33 years. Right, so because you're not going to put 2005 in place of x, you're going to put 33. So use your equation, y equals 3.5 over 26 times 33, and then plus 23.2. So in 2005, what is the median age for men to get married? Who knows? 26 times 33 plus 23.2, and the final answer is 27.6 rounded. So in 2005, this point right here is 27.6. Men are getting married even later. Okay. So instead of giving you 2 points like this, zero, I don't know, let me make it up. Point 4 and 3, and then 0.5 and -8, and saying, hey, give me the equation of this line, it's given to you in the context of a story. That's all we're doing today. 10. The cost for dance lessons, 7 dance lessons, 82. So basically, this is what you have, 2 points. This is the cost, and this is the lessons. But you have a point. The other point is that if when you get 11 lessons, you pay 122. Again, lessons and cost. So instead of just giving you the points 7, 82, 11, and 122, they gave you a little story with it. Let me graph this. So this is my cost, and this is the lessons. And let me put it on the graph. And this is 0. Well, obviously 0 lessons is going to cost me 0. I'm not going to say that. It's obvious, but it should cost me $0. But let's see if I'm right. But I know that 7 lessons over here, I have to pay $82. That's a point in the graph. And then if I take 11 lessons, I'm going to pay 122 right here. So I got 2 points. I don't know if it's proportional. I don't know if it's like this, right? Which means 0 lessons, I pay $0. Or it might be like this, which means at $0, I still pay something. Maybe a club fee, a dancing fee, shoes fee. I don't know. But we got to figure that out. We have 2 points, these 2 points, and that's enough for me to find the slope, right? So let me call this x1, sorry, x2, y2, and this is x1, y1. So we got 122 minus 82 over 11 over 7, minus 7. So that's 40 minus 4, which is 10. So here's my slope. That tells me that every lesson, so if you start substituting y equals mx plus b, y equals 10x. So every lesson is $10. Now, if you plug in 7 over here, you get that 10 times 7 is 70, but they're telling no, it should be 82. So there is an adjustment that we're going to make, and the adjustment is plus 12, right? So we can clearly find that. So is this a proportional graph? No, it's linear, but non-proportional, because it looks like this. And there's right here, $12 that I have to pay. So the lessons are $10 per lesson, but what's that 12? Maybe a club fee, a dancing fee, a shoe fee, something that you have to pay besides the lesson, and you only pay that once. Okay? So, and then says, find a cost of 4 lessons. Well, if I go there and I only want 4 lessons, it's y, $10 per lessons. I'm taking 4 plus my dancing shoes. So 10 times 4 is 40 plus my dancing shoes. I have to pay a total of $52. See, it's not that bad. Okay, so again, read it, try to understand it, draw a graph, draw your points, and then from there do the math, because the math is the easy part. It is 76 degrees at 6,000 foot level of a mountain and 49 degrees at 12,000 foot level of a mountain. Write a linear equation to find the temperature at any elevation of the mountain. Okay, so it seems like the higher you go, the colder it is. So does the temperature depend on the elevation, or does the elevation depend on the temperature? So the temperature obviously depends on the elevation. Right, and the higher you go, the colder it gets. So elevation is going to be here. and the temperature is going to be here. So let's see, we're going by 6, okay, so 6,000 feet, 12,000 feet. So it says at 6,000 feet, the temperature is 76. Here's the point. And then at at 12,000 feet, temperature is a little lower. It goes down. All right, so we have 2 points on this graph. This point here is 6,076. This point here is 12,049. Well, we can find the slope. X1, Y1, X2, Y2. So the slope is definitely going to be negative. So M equals 49 minus 76 over 12,000 minus 6,000. And let's see what that looks like. It's going to be negative 27 over 6,000. I'm going to leave it like that. So that's my slope. Y equals negative 27 over 6,000 X plus B plus the slope. Now, how do we find the slope? Well, sorry, the y-intercept. Well, we're going to pick either this point or this point, and we're going to use it to solve to replace x and y. Let's pick the lower one. So let's use 6,076. So 76 equals negative 20,000 over 66 over 6,000 times 6,000 plus b, cross, cross. And then we get 76 equals negative 27 plus b. We're going to add 27 to both sides. That goes away. And b, our y-intercept is 13, go on, 103. Right here is the y-intercept. Ha! I don't know what this is, but it says that at this particular elevation, the temperature was 103. Okay. So let's use that. So my equation is y equals negative 27 over 6,000 plus 103. And we're going to use that to find what the temperature is at 20,000 feet. So, sorry, I forgot the x here. Y equals negative 20,000 over 6,000 times 20,000 plus 103. So plug that in. Negative 27 over 6,000. Clear negative fraction of 27, 6,000 plus 103. Enter. 27 over 6,000. Oh my God. 27 over 6,000 times, what is it? 20,000. So I forgot a 0 here. Times 20,000. 1, 2, 3. Plus 103. Final answer. Sorry guys, there's something wrong here. Negative fraction 27 over 6,000 times what? Times 20,000, because that's the elevation. 1, 2, 3. Enter. Plus 103. Sorry, I get 13. Ugh. So at 20,000 feet, the temperature is going to be 13 degrees. Here we go. Okay. Ugh, apologies. Between 1990 and 1999, movie screens increased by about 15,000. In 1996, there were 29,690 movie screens. Write an equation. Okay, so we can write this like this. This is year. This is movie screens. We know that y equals 1500x because that's the rate of change, right, every year, but we don't know this guy here. So what we do know is in 1996, and that's where I'm going to start with, okay, because I don't know anything else. I don't have any other piece of information. So I know that in 1996, and I'll write 1996 over here, and that will be my year zero, the year that I actually started counting. The number of movie screens in the United States was 29,690. And then this starts growing, so 1997 would be year one. 1998 would be year two, right? Since I started recording this, and so forth, and so forth. So, and it starts growing. But the question here says, well, actually, let me finish. So that's going to be my slope, my y-intercept, 29,690. So that's what I'm going to use. That's going to be my base, right? Because I don't have any information for 1995, 1994. So at year zero, I finally decided to count, right? In 1996, the year I started counting movie theater, I counted 29,690. And then at 1 year after, how much did it grow by? It grew by 1,500. And then in 2000, there were 3,000 more. Year three, there were 4,500 more, etc., etc. So they want to know how many screens there were in 2005. Well, in 2005, how many years would that be after I started recording? Well, 1990. So we're going to subtract 2005 and 1996, and we get 9 years. So 9 years later, right here, right? How many movie screens were there? Well, let's use our little function here. 1,500 times 9 plus 29,690. So 1,500 times 9, enter, plus 29,690 give us that there is 43,190. So this point right here, and I'll change colors. When it says 9 years after 1996, there are 43,190 movie screens. Right? So let me just 43,190 screens. Oh no. Hang on, sorry. Charger. Oh my god. So we did that. And then we have a construction company. That should be easy. Sorry. Construction company. Now, do you have to graph this? Or, sorry, use... It just makes the visual so much easier to understand if you put a little display there. It won't kill you. Take the extra 2 minutes to do a visual representation. What in the world is going on here? Okay. Construction company charges $15 per hour. So there's my slope, right? Rate of change right there. So nothing to think about here. So we know it's 15x. I'm going to start. Plus a one-time fee for a trash dumpster, plus something, right? The total fee for 9 hours of service is 195. Write an equation. Okay, write an equation line. So think about this. Construction company, they come to your house or you hire them, right, to remove junk. So it's per hour. Here's the cost. 0 hours, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. 1, 2, 3, 4, 5. So imagine if they came and they haven't even started anything. Because it says there's a fee, we know it's not going to start here. It's not going to go through the origin. It's going to start here, whatever that number is. And it's going to go like this. Okay, so let me use that. I don't know. This is my y-intercept, so I don't know what that is yet. I don't know what that extra charge is, but I do know it's $15 per hour. So I do know that 6, 7, 8, 9, at 9 hours, right here, the total is $195. So I have a point that says at 9 hours, 195. Okay, I have a point. I have the slope. It's given to me, so a slope is 15. So I need the y-intercept. So let's use 9 and 195, right? We're going to replace the x and the y. So y equals 195, 15 times 9 plus b. 195, 15 times 9 is some number, 135 plus b. We're going to subtract 135 from each side. And b equals 60. So that's the extra charge that they're charging me. So they're charging me 15 bucks an hour, and this little guy here, it's 60. Okay, so I can now complete my equation. Y equals, he charged me $15 per hour plus that extra trash dumpster fee of 60 bucks. And here is my function. It's the relation. So now if I ask you for, hey, 15 hours, how much do I pay? 24 hours, how much do I pay? We can use this relation. So remember, here's an x and y, right? Think of your table. When 9 goes in, 9 hours of work, how much did I pay? 195. So if I asked you for 35 hours, you would be able to find, because what would you do? Multiply by 15, add 60. Multiply by 15, add 60 is the function used. What's the fee for the use of the trash for 5 hours? Well, there we go. So in 5 hours, let me find a corner right here. In 5 hours, so that's what they're asking. How much are you going to pay? Well, in 5 hours, we would go y equals $15 per 5 hours plus $60 for the dumpster fee. So y equals, and 15 times 5 is 75 plus 60, so a total of 135. So your y, your output would be 135. Pretty. Do you have, again, this guy here comes in so handy. So try to do it. There's more. Oh, never ending. Oh, okay. Long video. Okay. But it's just one question per page, so it's all right. The population, Josestown, 1995 was 2,400. Population, the second years since 1995, right in the UK. So, zero at the time that I started recording this, right, from the town population recorder. And it says here that in 1995, or the year I started, we call it year 0, there were 2,400 people in this town. And then in 2000, I'm not going to call it 2000, 2000 is going to be represented by 5 years later. 5 years later, I have how many? 4,000 people in this town. So that's what my line looks like. Can I find a slope and etc.? Yes, I can. Look, we have 2 points. This point and this point. This point is called 5 and 4,000, right? And this point on the graph would be 0 and 2,400. Let's find the slope. M equals 4,000 minus 2,400 over 5 minus 0. I get 1,600 over 5, and our slope is 320. So it appears that the population is growing by 320 every year. So y equals 320x plus b, and we have the b right there. Look, we already know what our b is. So let me write the full equation. Y equals 320x plus 2,400. So the bottom question, I don't know if you see it, what would be the population in the year 2010? A prediction. Well, let me write 2010. 2010 is how many years after 1995? It's 15 years after, right? So I want to know what this guy is here. And that's what I'm looking for. That spot right there. So the what's the x value? Well, so let me write this. 0, 2,400. So let me write that as a table. 5 years later, which is the year 2000, the town had 4,000 people. And then 15 years later, what's the population? That's what they're asking. So the input is 15. So y equals 320 times 15 plus 2,000. 320 times 15 plus 2,400 equals 7,200. So 15 years later, we can predict that the town is going to have 7,200 people. Randy owns a computer store. In 1990, he sold 150 monitors. In 2000, he sold 900. Same exact question as before. I have no information about anything prior to 1990. So in 1990, when I started recording the first year, right, the 0 year time, I started recording how much in sales he was doing. I can tell you that in that year, he sold 150 monitors. So this is years. This is monitors, right? In the year 2000, which is 10 years later, 2000, I asked him again how many monitors he sold. So 10 years later, he was selling 900. Let me put it over here. 900. So you know it's growing, right? Well, let's write a linear equation for this. So that's what it looks like, those 2 points. The trick part is you understanding that you're not going to write 1990 and 2000. So you write 1990 and 2000 is 10 years after. So those are the points. So this point over here is 10, representing 10 years after. He was selling 900 monitors. 0 at the beginning, he was selling 150. Those are the 2 points you're going to work with. So x2, y2, x1, y1. So we're going to do 900 minus 150 over 10 minus 0. So we get 750 divided by 10, and it's 75. So it appears that it's growing by 75 monitors per year. So let's look at our equation. Y equals 75x plus b. Do we have the y-intercept? Yeah, right here. Plus 150. Right, the number of monitors, he will sell in 2007. Well, let me write 2007. But in terms of years since we first started recording, 2007 is 17 years after. So what is, so 17 years after would be 75 times 17 plus 150. 75 times 17, enter, plus 150, it's going to give us 1,425. So in the year 2007, which is 17 years after we started recording, he's going to be selling, predict that he's selling 1,425. All right, last question for the love God. Gift shop in 1995 and closed in 2000. 1995 for inventory of stuffed animals 315. 2000 was 0. Let X, okay. So again, the hardest part for me is you knowing that the moment we started, although the year is 1995, on the graph is 0. Time-wise is time 0. So years. And in 1995, or the year the store opened, at 0 in the beginning, she had 350 stuffed animals. So that's the first point. That's our first point. That says that in the beginning, when the store opened, 1995, in the 0 year, right? She had 350. And in the year 2000, I'll put over here, her inventory was 0. So let me get another point. Right like that. And we can connect. And it says that it's 0, so we know when it closed. I need to get 2 points. Well, 1 point is right here. What is this point? 0 and 350. And this point over here is going to be, so first of all, I'm sorry. I wrote the year 2000, but the year 2000 is on the graph represented by the number 5, because that's 5 years after the store opened, right? So 1995 to 2000 is 5 years. So I have that point, and this point here is 5 years. In year 5 years, what was her output? 0 twice. Well, let's find the equation. So the equation is, so the slope is 350 minus 0, right? I'm going to make this, sorry, this is y2, x1, x2, y2. Oh my god. x1, y1. So 350 minus 0, and then to x2, which is 0 minus 5. We get 350 over negative 5, and that is negative 75. So every year she sells 75 stuffed animals. So our equation equals y equals, and it has to be negative. Look, our slope is going down. Negative 75x plus this guy right here, 350. That's the equation of the line. And what's the second question? In 1998, how many stuffed animals did she have? So this is what we're looking for right now. Let me 1995, 96, 97. So in 1998, which is 3 years after, right? How many stuffed animals did she have? That's the question. Well, y equals negative 75 times what? Times 3, because, right, that's the input. 3 plus 350. Y equals negative 75 times 3 is 225. Negative 225 plus 350. Y equals 125. So in 3 years, what was her inventory? She had 125 stuffed animals left. Okay. And you can create a table over here. Here's a table. In the beginning, 0, she had 350, what do you call, stuffed animals. And then at year 5, she had 0, right? Because she sold everything. So the question was, at year 3, how many stuffed animals did she have? Okay, that's it. Promise.